weeks from last Wednesday. We've got our test on complex numbers, and then 3 weeks from yesterday and 3 weeks from the day before yesterday. We've got our final.
What are we doing for the entirety of May?
The entirety of May. So in May, we've got polars that we need to talk about yet, and we've got parametric equations to talk about yet. We used to do a lot. See, the NTC final used to have a lot on parametric equations. So we always did parametric equations first, and then we did polars and complex numbers. They rewrote the final and took off all of the parametrics and put on more complex numbers. So we did complex numbers first this time, and then we could have maybe polars and parametrics. But parametrics are the fun stuff, because that's when we start launching stuff. And so we actually have this really cool lab where we launch a steel ball through a ring, and then we land it in a bottle cap.
Oh.
Yeah. So, yeah.
And then will there be a separate summative on that stuff?
Yes. Yep. And potentially, we haven't figured out if there probably will be another final thing too, or a second part of the final just on second semester stuff. Yep. All right. 2 good warm-ups here. Find me the product of them and the quotient of them. Yep. Go for it. Oops, that didn't help. Yeah, it's still not helping. Get an R value of 5 on that one. Get a reference angle of 53.130 degrees, yes? Going straight off of memory. I think that's right, isn't it? Yeah? 53? Okay. But because this is in quadrant 4, actual theta is going to be 360 degrees minus a reference angle. So that's going to be 306.870 degrees. Yes? Huh? So Z sub 1 here is going to be 5 cosine I sine of 306.870 degrees. Huh? Z sub 2 has an R value. Because it's 6 and 6, that's going to be a isosceles triangle, which means it's a right triangle, which means it's a 45, 45, 90 triangle, which means my R value is then going to be 6 square roots of 2. Because it'd be 36 plus 36, which would be the square root of 72, which is 36 times 2, which is 6 square roots of 2. Because it's a 45, 45, that means my actual theta here in quadrant number 4 is going to be 315 degrees. Yeah? So my Z sub 2 is going to be 6 square roots of 2 times cosine I sine of 315 degrees. Yeah? So then we're tasked with finding Z sub 1 times Z sub 2. Well, the first thing I do is I multiply my R values together. So that's going to be 5 times 6 square roots of 2 Then I add the theta values together. So that's going to be 621.87 degrees. So we got to subtract 360 on that. So I would get here that z of the product is going to be 30 square roots of 2 times cosine I sine of 261.870.
When we answer these, you want us to have the numbers in exact form?
Whenever possible. I mean, it's so much easier.
Okay.
You know what I mean?
So if you can keep the square root, keep it in there.
Might not always be able to, but.
This one was just easy.
Yep.
Split the second
Yep.
two. Okay.
Yep. Yep. What's up?
Would you still accept the answer on the test if it wasn't an exact form? Or
It depends on what we say on the test. If we say exact form, I want it in exact form. If we don't say, then it's either or. So then 30 square roots of 2 times the cosine of 261.87 is going to be negative 6.000. We're rounding to 3 because it's negative 5.99992497. So that would round to negative 6.00. And then 30 square roots of 2 sine of 261.87 should be negative 42. Now, if we would have done this exactamundo, kept it on our calculators and all that stuff, I rounded, okay? I'll admit that I rounded. If we would have done this exact, leaving this rounded answer, or this rounded angle from way back up there, we would have gotten negative 6 minus 42i. It would have come out exact there. Okay. Pick up the pace here. Okay. So then z sub 1, so then that's going to be 5 divided by 6 square roots of 2, and then it's going to be, we're 1 minus 2, so that's 306.870 minus 315 degrees. So this is going to be multiplied by the square root of 2, 5 square roots of 2 all over 12 cosine I sine of, so that's going to be like a negative 9. So we're going to have to add 360 to get that. Okay. The other one over here then was that, if we multiply that out. And we're exact. Okay. Decimal, negative 0.583 and negative 0.083 I on that one. We have the decimal. Okay. All right. Complex number. Take it to a power. What do I got to do? let me take a step back. What does 2 minus 2I square roots of 3, all of that to the 5th power, what does that actually mean?
Let's multiply the other 5 times.
Multiply the other 5 times? So really, this means yes, I am going to write it out. Yes, I can here. 1, 2, 3, 4. One more. Right? So now what do we got to do? Well, how am I going to be able to multiply them all together? How many can I do at a time? Can only do 2 at a time, right? Okay? So that's going to be 4. That's going to be minus 4I square roots of 3. That's going to be minus 4I square roots of 3. That's going to be plus 4I squared times 3. So that's plus 12, right? I squared, which is really minus 12. So this becomes negative 8 minus 8I square roots of 3, which means that these two over here would be negative 8 minus 8I times the square root of 3. But then I still got this one out here. Right? So now I got to multiply those all out again, right? There's got to be an easier way. Got to be an easier way. And actually, this cool French cat named De Moivre came up with it. Okay? And so what De Moivre said was, instead of leaving your complex number in standard form, let's switch it to trig form. Okay? So let's switch this to trig form. If I switch this to trig form, what is my R value here? So I'd have 2 squared, and I'd have to add that to negative 2 square root of 3. I'd have to square that, and then square root that. So that's 4, and that's 12. Which is 16. Square root of 16 is 4. Yes? Okay. Then I'd have to figure out my inverse tangent. So that's really just the inverse tangent to the square root of 3. Is that 30 or is that 60? That's 60. Okay? So that's 60 degrees. Which quadrant is my original complex number in? 4th quadrant. So my actual theta here is going to be 300 degrees. Yes? Okay? So now what I've got is I've got 4 CIS of 300 times 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 4 CIS of 300. Right? How do I multiply complex numbers in trig form? We just did one. We did a bunch yesterday.
You add the R's,
We add the R's.
and then you multiply them.
No, we don't add the R's.
Mine's
multiply the r's,
and then you add.
and we add the thetas, right? So this would be 4 times 4 times 4 times 4 times 4 CIS of 300 plus 300 plus 300 plus 300 plus 300. Right? 4 times 4 times 4 times 4 times 4. 1024? Do I like 1500 as a angle measure? Okay, so what do I got to do? Subtract off by 360, right? Okay, so we're at 1500 minus 360 gets me 1140. Minus 360 gets me 780. Minus 360 gets me 420. Minus 360 gets me 60, right? Okay. So that would be the trig answer, the trig form of that complex number. We could put that in standard form then, if we needed to. Multiply 1024 by the cosine of 60, which is 1/2, so that would be 512. Multiply 1024 by square root of 3 over 2, so then that would be 512 plus 512 squared, I squared to 3. Right? Okay? So de Moivre said, well, we can do this every single time. And so de Moivre came up with his theory saying that if we're taking a complex number in trig form, that we can just take the r value to the same power, and we can multiply the theta by the power. So the r value gets the power applied to it. The theta value gets the power multiplied to it. Then again, we'll have to adjust to get it back into first lap unit circle. I don't know why I should only put a shade on this one. Okay. Let's apply de Moivre's theorem. So we've got the complex number -3 plus 3i. And we're going to take that to the 4th power. Again, if you really love the math, you can do -3 plus 3i times -3 plus 3i times -3 plus 3i times -3 plus 3i. Okay? 100% you can do that. And then when it's done, you can put that into trig form and all that fun stuff. Okay? Or we can start by jumping right into trig form. Get an r value of 3 square roots of 2 right from the start. 9 plus 9 is 18. Square root of 18 is 3 square roots of 2. Okay? A and B are equal, so my reference angle is 45 degrees because the inverse tangent of 1 is 45 degrees. That is something that you should be able to recognize right from the start. You should be able to see trouble that when A and B are the same, that your reference angle is 45 degrees. Negative positive puts me in quadrant number 2, so actual theta then is going to be 135 degrees. Yes? Okay? So this is really saying that this is 3 square roots of 2 CIS of 135 degrees, and we're taking that to the 4th power. Which means I need to take 3 square roots of 2 to the 4th power, and I need to take 135 degrees, and I need to multiply it by 4, because that's my power. 3 square roots of 2 to the 4th power is 3 square roots of 2 times 3 square roots of 2 times 3 square roots of 2 times 3 square roots of 2, right? So that's 3 times 3 times 3 times 3, which is 3 to the 4th power is 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay? Square root of 2 to the 4th power. That's square root of 2 times the square root of 2. That's 2. And then I got another 2, right? So 2 times 2 is 4. So I've got 81 from taking 3 to the 4th power, and I've got 4 from taking the square root of 2 to the 4th power. So what's 81 times 4? 324. So this is going to be 324 CIS. What is 135 times 4? 540. Okay? Is that first lap? Okay, so we got to subtract off 360. 540 minus 360 is 180. We've been converting into standard form all week. So this would be negative 324 plus 0i. Because the cosine is negative 1, so 324 times negative 1 is negative 324. The sine at 180 is 0, so it's plus 0i. You try that one. Done. All right, so we got an R value here of, it's going to be 1 squared plus the square root of 3 squared. So that's going to be 1 plus 3. So I got an R value here of 2. Do we agree with an R value of 2? Yes? Because you should. Okay. Can go right to R theta because it's in quadrant number 1. So this is going to be the inverse tangent of the square root of 3 over 1. That is 60 degrees. So this becomes here 2 CIS of 60 degrees, all taken to the 4th power. So then that is going to become 2 to the 4th power cosine I sine of 4 times 60. Two to the 4th power is 16. So this would be 16 cosine I sine of 240 degrees in trig form. 240 degrees is, the cosine is negative 1/2, so that would be negative 8 minus 8i square roots of 3 for the standard form. Yes? With that being said, oops, I should circle my answer so that old people can find it. Wink, wink, nudge, nudge. Your homework, or what you can do in your homework packet, is now you can go all the way up to 24. Gives you 24 problems that you could get done, or, well, you should have at least 16 of them done by now, hopefully already. Okay? Don't procrastinate.